In this recording, we're going to review a pretty useful skill from Algebra 1, which is to write an equation of an exponential function given a table of values or a graph. So let's start with this table of values. We can see that as x increases by 1, we see a pattern here, right, in the y's. And that's critical, that we see a pattern and that pattern is a multiplier pattern. Okay, it's a constant growth. And the way to find that ratio, we call it, is just do a division here. So if I do like 15 divided by 5, okay, that constant ratio is 3, right? Times 3. So, all right, so it's times 3, right? And we get that by doing 15 divided by 5. So that's the constant ratio. And it turns out that's the base. That's the rate by which this thing is growing, is what's being multiplied by each time. And we can see that's constant each time. 45 divided by 15 is the same. It's 3 every time. Right? So that we know is our base. And then the question is, what's A? Well, A is the y-intercept, right? A is what happens when x equals 0. Because if x equals 0, then this whole factor becomes a 1, right? Anything to the 0 power other than 0 itself is 1. So we can, if we have a table here that has an x value of 0, we know that the y value is the y-intercept. So that's just 5. Now we can write an equation. So we can say y equals a times b to the x. So 5 times 3 to the x. And our explanation, well, b is the constant ratio okay, so it's what is being multiplied by each time, and a is the y-intercept. It's when x equals 0. So in our next example, we have a little more of a challenge. We know that f of 0 is 8 and f of 3 is 1,000. So this is a little challenging because these aren't consecutive points, right? It's a gap of 3, but we can figure this out. And we know what the y-intercept is, so that's important. It says, use the fact that f of 0 equals 8 to determine the value of a. Well, we know that in a function, when we have anything to the 0, so b to the 0 power times a, okay, that's going to be 8. Okay, so subbing in 0 for x, that's the x, and 8 for y, or f of x, well, we know that's a 1, right? So just 8 is a. And we've shown our thinking there, the substitution of 0. All right, so next, once we know that 8 is a, we can make some substitutions here, and we can know that, okay, again, we have an x value, and we have a y value. So let's make some substitutions and solve for b. So get as far as you can, and see if you can solve for b. So hopefully you paused and worked that out. So we've got 1,000, that's our y value, equals our a value, which is known to be 8, times we don't know, the base, to the x power, which is 3. So because we have only one unknown, we should be able to solve this. Remember, we undo operations in reverse order from our order of operations as we solve for a variable. So we're going to divide by 8, and that works out nicely. That's 125. Okay, so that becomes 125 equals b cubed. And of course, that's one of our perfect cubes, right? That's 5. So you could do the cube root of each side, or you could raise both sides to the 1/3 power. I'll just cube root it, I think. So 5 is b. And now we can write the equation. Oh, I guess I was supposed to solve that down there. I wasn't a good reader. All right. There's the work. And finally, determine the value of f of 2. So we know we have this function f of x we've already found is a, which is 8, times b, which is 5, to the x power. Let's go ahead and find out f of 2. Okay, so f of 2 would simply be substituting in 2 for x. That's mental math, right? 25 and 25 times 8 would be 200. Next. This one's a little bit challenging because it doesn't even give us the y-intercept. So, shoot, we don't have consecutive points, and don't know the y-intercept. So why don't you take a moment, try to get as far as you can with this, pause it, and then play the recording when you want some input or you want to check your answer. Okay, so here's what I was thinking for this particular question. We have an xy table. We have a point, this is again an x and a y, and an x and a y. So we've got something like this. We've got a 4 produces a 3. We don't know what 5 does, but let's just write the x of 5. And then 6 produces a 48. So there's a couple ways to do this problem, but one is to kind of think about, all right, the x's would be increasing by 1. The y's are increasing by some multiplier, some constant factor, right? So, well, this went up 2, grew twice. So this, the base should grow twice, but it's being multiplied each time. So the way to represent that is with an exponent, right? So if we were just to say what the base went up by, we saw that back in the beginning. The base is what we get when we multiply a y value. We multiply a y value by that base to get the next y value, or we divide, okay, that's what the b value is, we divide a particular y value by its previous y value. That's the ratio. So b squared, and well, we would divide it twice, so b squared is when we divide 48 by this factor twice, we get 48 over 3. Okay? And we know 48 over 3 is 16, so that's going to give us a 4. And you could have tested that out, I guess. You could have tried multiplying by 4 to see how that would do. Well, that would make it 12, and that would make it 48. So that should work out. Okay. Next question. So this one is even more challenging. Okay. Gives us 2 points here, and we're going to make a little system using y equals a times b to the x in both of these cases. So we've got an xy and an xy. We're going to write 2 little systems, y equals a times b to the x. So why don't you sub in both of those x's and y's, write your 2 equations here, and then play the recording when you're ready. Okay, so hopefully you wrote something like this. For the first one, we've got 36 equals a times b to the second. And then the second is 121.5 equals a times b to the fifth. It says go ahead and divide these 2 equations. Well, as long as I'm dividing both sides by the same value, then it's legitimate, right? And because these 2 sides are equal, I can divide 121.5 by 36, and I can divide the other side of the equation, a times b to the fifth. I can divide by something that's equal to it, which is a times b to the second. You might say, what allows you to do that? Divide both sides by different amounts. Remember, these amounts are actually equal. So I can use my calculator and do 121.5 over 36. I get 3.375. And the a's divide out, and the b to the fifth over b squared. Remember that little thing of where are there more b's? Well, there's 3 more b factors in the numerator. That gives me b cubed. Of course, I can cube root both sides and get 1.5. Nice. So, now that I've got b, we can find out, I guess I was supposed to do that, solve the equation for the base b. All right, we went ahead and did that. Now let's find out what a is here. So we can go back to either of these points. I kind of like this one, a little smaller, a little more manageable. So let's go with 36 equals a, which we don't know yet, so let's write it as a, b, which is 1.5, to the second power. Again, I'm using the x value of 2, the y value of 36. Okay, now just do this little math. It's 36 equals a times 2.25. And then you can just do your division, divide both sides, and we've got a equals 16. Okay. Now finally we can write our equation. Y equals a, which we've known to be 16. Oh, it's supposed to be a not equal. That was just kind of a little quirky thing. A equals 16 times b, which we found to be 1.5 to the x. Thanks for watching.